Welcome to Chapter 3. We are kicking off Unit 3 by hopefully doing a day of quite a bit of review. We are going to be using some old topics back from Unit 1 and just adding in a few little bits of definitions to go along with it. So the main unit that we are talking about here is solving a system of equations. And we are eventually going to learn 3 different methods to solve them. Today is the first method. Before we look at how to solve them, though, we need to know what a system of equations is. So our first definition is a system of linear equations. And that definition says it is 2 linear equations, or 2 lines, that have either one solution, no solution, or infinitely many solutions in common. Well, we're talking about solutions here, so the next logical definition would be, what does it mean to be a solution to a system of equations? A solution to a system of equations is simply a point that, when substituted into both equations, makes both equations true. In other words, you can plug the numbers back in to both equations and you will get a true statement. So that's our big goal, is what is that point that is the solution. So the next thing we are going to look at, since we're focusing on graphing today, we're going to look at our 3 different types of problems that you're going to see. The first one you see here, this is the most common of your problems that you're going to see. You see one red line, you see one blue line. They are obviously crossing at one point, and that point is right here. So let's see what information is important about this system. This is considered a system where the lines intersect, as we can obviously see. This will be a problem that has exactly one solution. It's the black dot that I just made. When you are going to write your final answer, you actually write an x and a y coordinate. You would count left or right for x. You would count up or down for y. You would write a coordinate of that black point. So for instance, this example, the black point, I am going left 1 and down 1. So it would be -1, -1. That would be your solution to this system. This is also referred to as a independent system. This is the most common problem you're going to be seeing in today's notes and in your homework. The second type of system, as you can see here, there's also a blue line and a red line, but notice they don't touch. These are obviously what we're referred to as parallel lines. So let's learn some information. In this system, the lines are obviously parallel. That means that they never ever touch. So if they never ever touch, there is never going to be a solution to them. So that is why when we have problems like these, the automatic response is no solution. And this is called an inconsistent system. Our final system, as you notice, we don't have a blue and a red line. But the reason for that is they're right on top of each other. If you put blue and red on top of each other, they mix together to make purple. There's actually 2 lines there. They just happen to be the exact same line. In this system, the lines are exactly the same. They lie on top of each other the entire time. And because they lie on top of each other the entire time, they have lots and lots of points where they touch. They touch right here, and right here, and right here, and here, and here, and here, so on and so forth. Because they touch a whole bunch of times, we actually call this a solution that, or a system that has infinitely many solutions. In other words, there isn't one, there is whole bunches. This is also referred to as a dependent system. So today, every problem you see will be one of these 3, and you will either give me an x and a y pair like this, or you will tell me no solution, or you will tell me infinitely many solutions. So that being said, we're going to jump right into the examples. Let's look at the instructions on what I want you to do. First, put both equations in slope-intercept form. In other words, get y by itself so that your equation looks like y equals mx plus b. That's a skill that you're going to have to get good at. Then, graph both lines on the exact same graph. Now, this is a suggestion that will make your life easier. Be sure to use as many points as you can fit on the graph. The more points you can make, the more accurate your line will be. Then finally, once you're done, you're either going to tell me the x and the y, or you're going to tell me no solution, or you're going to tell me infinitely many solutions depending upon what you see. Let's look at example 1 together. First thing we need to do is get y by itself. So I'm going to draw my line down the middle. I want to move the 2x, so I'm going to subtract 2x. That leaves me with negative 2y equals negative 2x minus 8. I'm then going to divide everything by negative 2. I am left with y equals negative 2 divided by negative 2 is positive 1x, and negative 8 divided by negative 2 is positive 4. This line is ready to be graphed. I'm going to go ahead and graph that. My starting point is the 4. So I'm going to go up 1, 2, 3, 4, put a dot. My slope is 1 over 1. So I'm going to go up 1 and right 1. Up 1 and right 1. You want to keep repeating this with as many points as you can fit this direction. When you run out of space, you want to go the other direction. I'm going to go back here. Instead of going up and right, I'm going to go down and left. Because notice, they stay in a straight line. The more dots you make, the more accurate your line is going to be. Okay? So now you have a whole bunch of dots you need to use your IDs for this lesson. Absolutely no hand drawing lines. It must be straight. So I'm going to draw a straight line with arrows going through every single one of these dots. Well, let's make that a little thinner real quick, so it's easier to see. There we go, that's better. Okay, I'm going to change colors to keep things a little organized. I'm going to come over to this other equation. So I need to do the exact same thing. I want to move the 2x to the other side. I'm going to subtract 2x. I am left with 2y equals negative 2x plus 4. I need to get rid of this 2 by dividing. I am left with y equals negative 2 divided by positive 2 is 1x, and 4 divided by 2 is positive 2. So this time, I'm starting at positive 2. So I'm going to go up 2. This time my slope is positive 1. I'm sorry, our slope was negative 1 over 1. So I'm going to go down and right 1, down 1, right 1. Again, continuing as many times as I know I can fit. This problem, maybe you don't need that many. Notice they just crossed. But some of your other ones, you will need lots and lots of dots to make sure that you are accurate. So then I'm going to draw my line. I will also make this one blue to keep the colors separate. So, simply looking at this problem, we can obviously see that these two lines intersect. They intersect right there. What I need to know, and this is the final step of the process, I need an X and a Y that lead me to that dot. So from 0, 0, first I count left or right. I'm counting left 1, which means it's a negative 1. Then I am counting 1, 2, 3 up, which means it's a positive 3. And that is what you're doing on your homework tonight. So that being said, why don't you guys pause the video and see if you can get your letters by themselves. On this one, get Y by itself and try and graph. Okay, so let's see how you did. Put on my line. We know we need to move the X, so I'm going to subtract 4X. That leaves me with negative 3Y equals negative 4X minus 15. Divide everything by negative 3. Y equals. This is where you need to use the calculator to help you reduce. Negative 4 divided by negative 3 will be a decimal, but if you hit math, enter, enter, you end up with positive 4 over 3x. And yes, I expect it to be positive, and yes, I would take off if you left them both negative. And negative 15 divided by negative 3 is a positive 5. So, let's start with our starting point right here. We are going to go up 1, 2, 3, 4, 5. My slope is positive 4 over 3. So I'm going to go up 4 and right 3. Now I already ran out of space. Go back to where I came from. Instead of going up and right, I go down and left. Down and left. Down and left. Then I connect them with a nice straight line. That goes completely across the graph. The long lines are necessary because you never know where those graphs are going to intersect. Okay, so let's switch over to the other equation. I got to move my x again. First of all, that's a 1 in front of that x. So we need to subtract 1x. That leaves me with 2y equals negative 1x minus 1. We're going to divide everything by 2. Negative 1 divided by 2, put back into a fraction, stays negative 1 over 2x. The y-intercept you can write as a decimal. Negative 1 divided by 2 is negative 0.5. So this one may be a little different for you guys to graph. So we're going to start at down 0.5. So I'm going to go down a half a box. I'm in the middle of a box. I now need to go down 1 full box and right 2. Down 1, I'm still in the middle, right 2. Down 1, still in the middle, right 2. Continue that pattern until you run out of space. Go back, go up 1 box and left 2. Up 1 box, left 2, up 1, left 2, up 1, left 2. So we are ready to draw in that nice pretty straight line. So as you can see, they definitely intersect. Again, they are intersecting right there. We need to know the x and the y. Well, from 0, 0, I'm going 1, 2, 3 to the left. That's a negative 3. Then I am going 1 up. That's a positive 1. And that is your final answer. I'm going to have you guys try the next one on your own as well. Okay, so let's see how you did. Hopefully, you didn't let these frustrate you. These are graphs you need to be quick to recognize. If I look at this first equation, y is by itself. However, it is only the letter y. There is no x. When y is the only letter, this is a Hoy problem, which means we have a horizontal line. So I'm going to go 4 on the y-axis, 1, 2, 3, 4, and I am going to draw a nice horizontal line. Then we look at the second equation. Well, this is x only. There is no y. When there is x only, it is a Vux line. Vux meaning vertical. So this time I'm going to go to 7, but it's on the x-axis. So I'm going to go 1, 2, 3, 4, 5, 6, 7 to the right. And I'm going to draw a vertical line. And as you can see, they definitely cross. They cross right there. So we are ready to write our pair. Starting in the middle, I need to go to the right. 1, 2, 3, 4, 5, 6, 7. So positive 7. And then I need to go up 1, 2, 3, 4. So positive 4. And that one is done as well. All right, turn the page. And you guys try the next one on your own. Pause the video. Okay, let's see how you did. All the same process. I'm going to start by subtracting 2x. That leaves me with 4y equals negative 2x plus 12. Divide everything by 4. I am left with y equals. Now, negative 2 divided by 4 is a decimal, but when you hit math, enter, enter, you get negative 1/2 x. And 12 divided by 4 is positive 3. So let's go ahead and start at our starting point. I'm going to go up 1, 2, 3. My slope tells me to go down 1 and right 2. So down 1, right 2. Repeat it as many times as it takes to fill up that graph. And draw the line that connects them. Okay, let's switch over to the other equation. So we need to move the x. Again, that is a 1 in front of that x. So we are subtracting 1x from both sides. That leaves us with 2y equals negative 1x plus 6. Divide everything by 2. That leaves us with y equals negative 1/2 is already reduced. And 6 divided by 2 is a positive 3. Now, if you happen to notice, we're starting again at 3. Whoa. Sorry for that, guys. So we are starting again at 3. So I'm going to go up 3. I'm then going to go down 1 and right 2. Well, look at what happens. We are falling on top of our line that we just drew. If you end up redrawing the exact same line, if you remember, when they lie on top of each other, and we'll reference back, when they lie on top of each other, which was what this was over here, we write infinitely many solutions. So I'm going to go back to example 4, and I'm going to write the phrase infinitely many solutions. So the graph is required, but so is this phrase. All right, last example. Give it a try, guys. Pause the video. Okay, let's see how you guys did. That's a 1 in front of that x, so I'm going to subtract 1x from both sides. That leaves me with negative 2y equals negative 1x plus 5. I am going to divide by negative 2 everywhere. That leaves me with y equals a negative 1 divided by a negative 2 is a decimal, but when you hit math enter, you end up with a positive 1/2 x, and 5 divided by negative 2 is negative 2.5. So let's go ahead and graph this one. We're starting down 1, 2, and a half. We're going to go up 1 and right 2, up 1 halfway up, over 2, up 1, right 2, continue the same way the whole time. Go back here, do the same thing. And connect them with a nice straight line. And let's look at the second one. Now, I'm guessing this one is going to confuse some of you guys. Remember, you need to get y by itself. So don't move the x this time. Move the 10. I'm going to add 10 to both sides. I am left with 1x plus 10 equals 2y. I'm going to divide everything by 2. I am left with y equals 1/2 is already reduced, and 10 divided by 2 is 5. So I'm going to start at positive 5. So up 1, 2, 3, 4, there would be 5. I'm going to go up 1 and right 2. Up 1, right 2, up 1, right 2, up 1, right 2. Same thing over here, down 1, left 2, down and left. What do you notice about these two lines? Hopefully, what you are thinking right now is, hey, these are from geometry. This is a parallel lines. Because that's what they are. These lines will never ever touch because their slopes are exactly the same. And so when we have two lines that never touch, there's no way of finding an answer, so we write no solution. And that is the end of your notes. So you can start on your homework if you would like. If not, I will see you in class next time.